Today we're going to do something a little bit different in order to learn how to graph polar equations. And so the first thing it's going to tell us to do here is, in order to graph it on our calculator, we're going to explore what these look like on a graph. So it tells us to set our mode to radians. So we're going to want to go to mode on the calculator and make sure that it is in radian mode instead of degree. And then after that, it tells us to set it in polar mode. So on the very next one there, it says function, and then parametric and polar is what we're wanting to work with right now. We are going to have to adjust the windows to do that. And so we suggest your window be from 0 to 2 pi. And so you can just put in there 2 and then pi. It will go ahead and change it to the 6.28, which is fine. That's what we want. And then for the angle step, we're going to go to second pi. I'm sorry, the caret symbol to get the pi. And then we're going to divide by 24. That's going to give it small enough to where it will allow us to have a good picture on here. And then for our x min and x max, I did -9 and 9. That'll give us a good window for us to see these graphs. Now, when we go to our y equals, it says r equals, which is what we want. We want it to say r equals so we can graph these right here. 4 cosine of theta. And then I hit graph. And so there is the first graph. And so what we're going to do is, you're going to want to use the calculator to graph the first two, and then try and guess what the other two would look like. So right here, we've got this circle. It looks like it's going 1, 2, 3, 4, and it does go through the pole right there. So we got a circle that looks like this. We're going to go to our y equals now. We're going to do 2 sine of theta and graph that. And so now we've got another circle. In this case, it is above the pole. So I'm going to go 1, 2 on the pole, and there is my circle. Now try and take a guess at what the next two would do in order to, so that we can start practicing on what these polar equations look like. So go ahead and try and sketch what the next two you think are going to look like. All right, so hopefully you guessed something like this. We got a circle here and a circle here. And so when you're doing this, we're going to try, it says for the hypothesis here. So what conjectures can we make from what we're looking at? Well, if we look at these graphs here, every single one of them is a number and then cosine of theta or sine of theta. So we're going to label that as r equals a cosine theta, or r equals a sine theta. The next thing I should point out is that this number 4 here, that's 1, 2, 3, 4. For this one, it was 1, 2. For this one, it is 1, 2, 3. So that value up in the front is giving us the diameter of our circle. And then the last thing that you should have, or the big thing that you should have recognized, was that the cosine of theta has the circles on what would be like the x-axis or the horizontal axis, and then the sine of theta has it on the vertical. And so when it was positive, it went to the right. And when it was negative, it went to the left. And for the vertical, when it was positive, it went up. And when it was negative, it went down. All right, and the last thing you should notice on those circles is that there is one point on the pole every single time, and the other part goes out. Now we're going to look at our next one here, and we've got on this one, r is equal to 2 plus 2 cosine of theta. And again, we're going to start by putting this in our calculator. So I'm going to do 2 plus 2 cosine of theta. And then we hit graph. And so we've got this picture drawn on our calculator now. I noticed that it goes 4 units to the right here. So 1, 2, 3, 4. It goes up 2 and down 2. So from the pole, I'm going to go up 2 and I'm going to go down 2. And then it makes like this heart shape right there. So there's our graph. I'm going to do the same thing for the next one. We've got 3 plus 3 sine of theta. And in this case, we have pretty much the same shape, but now it's headed upward. And so it is going 1, 2, 3, 4, 5, 6 up, and then 1, 2, 3 in the opposite direction there. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3. And so there is our graph. Go ahead again and try and figure out what is going on with that and try and sketch the picture for the next 2, and then we'll summarize what we see on these shapes. So hopefully your sketches look like this. The first graphs drew a circle. These next graphs drew something that looks kind of like a heart. It is called a cardioid. So it's like a heart shape that it draws there. And so some of the things that you want to think through this, when it was cosine, our fatter section or wider part there was on the horizontal axis. When it was sine, our bigger part here was on the vertical axis. So that's one of the things that we want to recognize with these. A couple other things that you should recognize is that there is a point on the pole on all of these as well. The value that it goes on to the opposite direction as the fat part is the same value that's here is 2. So it went 2 up, 2 down. Here it went 3 to the right and 3 to the left because that's that A value. The next thing is that point that's furthest away. 3 plus 3 would be 6. And so this is 6 units this way. 2 plus 2 is 4. So it would be 4 units this way. I'll go ahead and summarize those on the bottom there. All right, again, so when it's sine of theta, our furthest point is going to be vertical. So it is going to go up if it's positive, down if it's negative. And we're talking about that sign right there. And then we're on our cosine of theta, it's going to go to the right if it's positive like this one, or to the left if it's negative. And again, we're talking about that sign. It is a distance of A plus B. So you take the two numbers together and you add them, and that's going to be the distance from the pole to that farthest point. For A is the point on the opposite axis. So this would be my opposite axis, and I would go 3 units there. There's always a point at the pole, so keep that in mind as well. We've got 3 more shapes on the back now. So let's talk about those. Again, we'll start by putting it in the calculator so you can see what that looks like. And so here we've got 4 plus 2 cosine of theta. And so we get a shape that looks like this. It looks almost oval or circular, but it's got a little flat side right here. And for most of these, it does get a dimple or a flat side. So go ahead and put that on our paper. We've got 1, 2, 3, 4, 5, 6 this way. So I'm going to go. Then it's got 2 the other way from the pole. Up and down, it's got 1, 2, 3, 4. So I'd go 4 up and 4 down. And so it's kind of flat over here. So it looks a little bit like this. It'll probably be a little flatter. There we go. All right, for our next one, we're going to get 3 plus 2 sine of theta. This one looks like it's doing a lot of the same stuff that we've seen on the other ones. Because it's sine, it looks like it's going upward instead of the horizontal that we saw on the other one. It does go up 1, 2, 3, 4, 5, and then it's going 1, 2, 3 to the right and 3 to the left. So let's get that on our graph and then try and go ahead and sketch the other two pictures and come up with some conjectures on what is happening with this graph. All right, so here is all of the sketches there. And so let's talk and summarize what we found by graphing these. So in this case, the equations were r equals a plus or minus b cosine of theta, or same thing with the sine of theta. In all of these cases, the a value is greater than b value. So when the equation is written like this and the a value is greater than the b value, it is going to form a limacon without a loop. That's what these are called. A plus b is going to be the far point from the pole. A minus b is going to be the point closest to the pole. So there is not a point on the pole in these particular graphs. The distance here is the a minus. So when we had here 4 plus 2, so if I take 4 minus 2, that gives me 2. So we've got 2 units here. And 4 plus 2 is 6, which is this longer part. On this opposite axis, we're going to have that a value. So this went 4 up, 4 down. Same thing here. This one was 3. So we went 3 to the right, 3 to the left. 3 plus 2 is 5. So it goes 5 units up. And then the difference between those two is 1. So I've got 1 unit in between this part here. Just like with our other graphs, the cosine works horizontally and the sine works vertically. You're going to find that's true for all of these. All right, our next one. We've got 2 plus 3 cosine of theta. And so here is our graph on that one. This is the one with the loop. So we said a limacon without a loop is this one. This is the loop right here. So these are going to be limacon with the loop. All right, so the difference between those, in this case, A was greater than B. So our number in the front here was bigger. And that's what made that limacon without a loop. Here, the number in the front is smaller. So that's what's going to do the limacon with the loop. So this one will be without the loop because the number in the front is bigger. This one will be with the loop because the number in the front is smaller. So go ahead and graph those on there, and then we'll summarize our findings. All right, so here is our sketches of those graphs, and you see that loop is in the center here. Again, we are working when cosine, it's horizontal, with sine, it is vertical. And so here the A was less than B, so we say that's a limacon with a loop. A plus B is the far point, and so 3 and 2 here, when we add those, we get 5. And so this point to the furthest point is 5 units long. Then B minus A is the loop point. So 3 minus 2 is 1. So we've got a small little loop right there of just 1 unit. Then on the opposite axis, it's still that A value up in the front. So I would go 2 up and 2 down. And so it's going to come down, loop, and go around. That's going to be true for all of the ones where our A value is smaller than our B value. You need to start being able to recognize those equations so you know what the picture is going to look like. Our last polar here that we're going to graph is the 3 cosine of 3 theta. And so the big difference here is that the angle is being multiplied times 3. So we get 3 cosine, 3 theta. And when I graph, I get this, oh, you can see that picture right there. That is called a rose. And so this particular rose has 3 petals. So you would graph that on there to see those 3 petals. I'm going to go ahead and graph this one on there so you can see the difference between that one. Sine 2 theta. And so there's our rose, and that particular one has 4 petals. So go ahead and sketch these on the graph, and then we'll summarize our findings on that too. So there's our rose graphs. You should have gotten something that looks like this. On the bottom here, let's summarize. So in these equations, it is A times cosine of n theta. and r equals a times sine of n theta. So the difference between these graphs and the other ones, or the other equations we've been looking at, there is no plus or minus here. We only have an a value. We don't have a b value. And there is a number being multiplied times our angle here. That's what makes it that rose, having that number multiplied times the angle. And that number is important. If that number is even, then that's how many petals are going to be found on the rose. If that number is odd, then it is going to be 2 times that value to get. And sorry about that. I just wrote that backwards. That should be the other way. Glad I caught that. That's backwards. If the number is odd, it's going to have that many petals. If it is even, it is going to be 2 times. So here we had an even number of 2, so there were 4 petals. Here we had an odd number of 3, so there were 3 petals. So make sure you get that correct on your notes there because I flipped them. The petals are evenly spaced, and under here I put the cosine ones. The petals are on the axis, the x-axis really. So right here, and then these two are split the other way. The other cosine one right here, we see that it starts right here on the x-axis, and then the other petals are evenly spaced away. For the sine one, they are not on an axis. They are usually evenly spread out that way. Since this one had 3, we do have 1 on the bottom, and then these 2 are spread out. But on the x-axis, there are no petals for the sine curve. So the easiest way to graph these are by learning those rules. In most cases, the rules are the same. So a plus b gets you that furthest point away. Once you start to recognize them, it is easy for you to figure out where the points are. However, if you can't do that, you could always create a table of values. And so here we see r equals -3 times the cosine of theta. And so we can create a table of values. Here's my main points on the unit circle. And so I can go -3 times the cosine of 0, which is my angle. And so at cosine 0, that's 1 times -3 is -3. And so then I would do -3 cosine of pi over 2. At pi over 2, our cosine value is 1 times -3 is -3. -3 cosine of pi. And so cosine of pi is -1 times a -3 is a +3. And then -3 times the cosine of 3 pi over 2. At 3 pi over 2, our cosine is 0. Mess this up. Our cosine there was 0. 0 times -3 is 0. At 3 pi over 2, that is 0 again, times -3 is 0. All right, so let's just do a sketch pretty quickly of this right here. And so at 0, it is -3. Well, this is 0 right here. So -3 would be 1, 2, 3 in this direction. At pi over 2, well, that's up here, pi over 2. It is 0 again, so that gives us this point. At pi, it is 3. Well, this is pi right here, and so 1, 2, 3 would give us this point right here again. And then at 3 pi over 2, that's this one, it is 0, so it would give me this point right here. And so that is the circle right there. So you will see that you can graph it by creating a table of values as well. I think it's a little bit harder with the table of values. You really have to think through the points, and you still have to be able to identify the graph by looking at it. Knowing that a times the cosine of theta creates a circle, then allows me to create this table of values. And when I put this here, then I know what the shape looks like. If I went to something like this, the 2 and the 2 are the same, so I know that's a cardioid. And then I would create my table of values by plugging the 0 in for the angle, plugging the pi over 2 in there for the angle, which gives me 2. I plug in pi for my angle here, and that gives me 0. And then I plug in my 3 pi over 2, and that gives me 2. Now when I graph, this is 0. I'm going to go out 4 units, and so there it is. At pi over 2, which is this one, I go 2 units, and there it is. At pi, it says I go 0 units, which is this one. And at 3 pi over 2 here, 3 pi over 2, it is 2 units. So I would go 2 units there. And so in order to finish graphing this, I need to know what this looks like. A cardioid is the one that looks like a heart. And so there is my graph. So if you know what it looks like, you can also create a table of values to graph it. You should be able to graph them, and then you should be able to recognize the equations both. So that's graphing our polar equations.